Hi. We're given a list and are to chunk it up into chunks of a given size. There are multiple ways to address this problem, but I think the simplest one is to use partition enclose. Here's a test case. The way partition enclose works is that it takes one element as left argument for every element on the right. That element is I count the number of new sections or segments that begin with this element. If we restrict that to Boolean, then it is just a true-false indication of whether we start a new segment here or continue the previous segment. So we have 7 elements here. Let's start a segment with the, continue with cat in the same segment, in goes there too. Then the, with lowercase t, is its own segment because we immediately start a new segment with hat, and we'll include set in that same segment, but pat gets its own segment at the end. Partition enclose on that list. So our real problem is just to construct a Boolean vector that, given our chunk size, has a 1 every n elements. Let's create a lambda, or anonymous function. We call it a div. The list goes on the right, according to the spec, and the chunk size on the left. Inside here, alpha refers to the left argument, because it's the leftmost character of the Greek alphabet. We can use this to take elements from a1. The way take works is to pad with an appropriate fill element if there aren't enough elements. Here we have a 1 in a group of 3 Boolean numbers. We just need to repeat this pattern until we get the full length of our list. The list itself is omega, the rightmost character of the Greek alphabet. And the length of it is this tally mark. Now we can take this length and use the reshape. It's a Greek row, which is like a letter R for reshape. And we use that to reshape that 100 pattern that we created before. APL functions have long right scope, so we need to parenthesize the left argument to the reshape function, but not the right argument. Finally, we need to take this Boolean vector and use it to do the partitioning. So we can, again, we have long left scope, long right scope, and short left scope, so we need to parenthesize the left argument, and then we use this to do the partition enclose on the right argument. I like to reduce the number of parentheses that I have, and therefore, when I have a very straightforward argument on the right, it's just a single token here that wouldn't need parenthesization if it was a left argument, then I like to swap the arguments of the function in question. So partition enclose, it takes the mask on the left, the data on the right, but there's a higher order function, or something we call an operator, called commute, which looks a little bit like a confused face because it gets confused about what's right and what's left. It modifies the function to its immediate left so that it takes its argument in the opposite order. This means we can move the partition over on the left, remember to commute it, and then put the right argument reference as left argument to partition enclose. Now we can try this with various lengths. If we go down to 2, we get pairs, and the last one stands alone. 1, we can see we get an extra enclosure of each element. If we go to 6, then almost all of them elements are in the same. 7, we also get an additional enclosure, just a single element. And if we try to go above that, then there's no difference because the specification is we just shorten. And this is what the mask indeed does. Thank you for watching.